Question number 11.20. How following conversion carried out? Means we have to write down the reaction. The first number, propene to propane to all. Now first of all, draw the structures of both compound. You can see propene, that is our starting material. 3 carbons in that double bond is there. Now ending material, that is propane to all, means 3 carbons. On second number carbon we have OH. Now look at the difference between these two. Here a hydrogen is more and OH group, that is extra. So H and OH, they both are extra here, means we have to add H2O here. So here I have written H2O and H plus. Now this reaction follows Markovnikov rule. If there is a question that says propene to propane 1 all, then you have to use anti-Markovnikov rule. So what will you do? Just add a peroxide with this. You can write peroxide only. That will give you anti-Markovnikov product. Means this OH will be shifted on first number carbon. Okay. The second conversion, benzyl chloride to benzyl alcohol. So first of all, draw the structure. You can see this one is our benzyl chloride or benzene ring, that is CH2OH. This one is our benzyl alcohol or benzene ring, we have CH2OH. Now what is the difference between these two? Instead of Cl we have OH here. So this is substitution reaction. So substitution reaction we have learned SN1 and SN2. So this one is SN2 reaction, aqueous NaOH reacts with benzyl chloride to give benzyl alcohol and NaCl. Okay. The third one, ethyl magnesium chloride to propane 1 all. Okay. So first of all you have to draw the structure of ethyl magnesium chloride. Ethyl means 2 carbon. You can see 2 carbons are here. With that magnesium and chlorine is attached, so MgCl. So you can draw the structure of ethyl magnesium chloride. That is our first starting material. Our product is propane 1 all. So you can see this one, 1, 2, 3 carbons, and on first carbon we have OH group, means it is propane 1 all. Now what is the difference between these two? 1 carbon is extra. You can see in starting material we have 2 carbons, in product we have 3 carbons, so 1 carbon is extra, and instead of MgCl we have OH group, alcohol group. Now we have learned preparation of alcohol, in that this one is our Grignard reagent. That reactions were there, Grignard reaction. Now what will you do? The extra carbon, number of extra carbon is 1 here. So take 1 aldehyde that contains only 1 carbon. So I have taken this aldehyde. Okay, formaldehyde it is, or you can say methanol. Okay, so 1 carbon is extra, so I am taking aldehyde that contains 1 carbon only. Now what will happen here? This alkyl group that will attack on carbon and MgCl that will go on oxygen. Again, alkyl group that will attack on carbon and MgCl that will go with oxygen. So this will be our intermediate, CH3CH2 CHH. This carbon is of aldehyde. You can see CH3CH2 that is attacking on carbon. These 2 hydrogens are as such. With oxygen MgCl attaches here. Now in second step, react it with H2O. So what will happen here? Just add hydrogen with oxygen here. OH will be formed. You can see here. And remaining OH part of water molecule that goes with MgCl, MgOHCl, that is our byproduct. Okay. The next one, fourth number, methyl magnesium bromide to 2-methyl propane 2 all. Okay. Here we have methyl magnesium bromide. So draw the structure of starting material. Methyl means CH3, with that magnesium and bromine is attached. So MgBr, that is our starting material. What is our product? Product is 2-methyl propane 2-ol. Means propane means 3 carbons. You can see 3 carbons are here. On second number carbon we have methyl group, and on same carbon we have alcohol group. So you can see alcohol and methyl group, they both are on second number carbon. Now you can see the difference between these two. What is the difference? Total 3 carbons are extra, and instead of MgBr we have OH group. Again, total 3 carbons are extra in product, and instead of MgBr we have OH group now. Again, you have to do the same thing here. As second starting material, I have taken 3 carbons that is having ketone group. Again, ketone which have 3 carbons means it is acetone. That is our second starting material. How will you derive that? You have to check how many carbons are there extra. So 3 carbons are extra, and it is 3-degree alcohol. You can see it is 3-degree alcohol. If 3-degree alcohol you want to prepare, you have to take ketone as starting material. So this one is our starting material, acetone, or you can say propanone. Now when it reacts with methyl magnesium bromide, what will happen here? This alkyl group means CH3 will attack on carbon, and MgBr that will attach with oxygen. So you can say CH3, CH3, that are 3 carbons are as such. On second number carbon we have CH3 group, and on oxygen we have MgBr. Now react it with H2O. H2O will break into H plus and OH minus. Now this H plus goes with oxygen to form OH alcohol group, and OH minus that goes with MgBr to form MgOHBr. Okay. Now question number 11.21. Name the reagent used in following reaction. Now means we have to just name the reaction. We don't have to write whole reaction here. First number, oxidation of 1-degree alcohol to carboxylic acid. Okay, so in first reaction we have 1-degree alcohol, and it is oxidation reaction. Now there were 2 types of oxidation reagent, weak and strong. As product we have carboxylic acid. So to make carboxylic acid from alcohol, we require strong oxidizing agent. Again, to prepare carboxylic acid from 1-degree alcohol, we require strong oxidizing agent. So here I have taken strong oxidizing agent, KMnO4 in basic medium. Okay, or you can take acidic medium also. KMnO4 is important here. KMnO4 in basic or acidic medium, that is our reagent. Okay, the second number, oxidation of 1-degree alcohol to aldehyde. Again, starting material is same, 1-degree alcohol. Oxidation reaction, that is also same, but product here is aldehyde. Now if you take KMnO4, it will give you acid only. Strong oxidizing agent cannot give ketone or aldehyde as product. So we have to use weak oxidizing agent here. As weak oxidizing agent we have CrO3 or PCC, pyridinium chlorochromate. Again, pyridinium chlorochromate, that is PCC. These are weak oxidizing agent that can give you aldehyde or ketone as product. Okay. Number 3, benzyl alcohol to benzoic acid. Again, alcohol to carboxylic acid, benzoic acid. So again we have to use strong oxidizing agent. So you can see I have taken KMnO4 in basic medium, strong oxidizing agent. The fourth number, dehydration of propan-2-ol to propene. Okay, so we have to remove water molecule from propan-2-ol to prepare propane. So it is dehydration reaction. For dehydration reaction, we have to take concentrated acid. So here we can see, for that we can use strong acid like H3PO4 or H2SO4, that is concentrated. Okay, so if you use concentrated acid, dehydration reaction takes place and you can prepare propane, alkene. Okay, number 5th, butane-2-on to butanol. Now this one is different here. Butane-2-on, that is ketone, and from that we are going to prepare alcohol. You can see this one is ketone. From that we are preparing alcohol. So you can see hydrogen is extra here. So it is reduction reaction. Again, it is reduction reaction. Now for reduction we have different type of reducing agent also. Strong reducing agent, weak reducing agent, that we have learned. So for ketone to alcohol we can use strong reducing agent or weak reducing agent. So here I have written both. NaBH4, that is weak reducing agent, and lithium aluminum hydride, LiAlH4, that is strong reducing agent. This both we can use. Now the next question, write names of reagent and equation for preparation of following ether by Williamson synthesis. Okay, so here in the question we have here product. We have to write down the starting material. Okay, so for that what we have to do, look here. First example, 1-propoxypropan, that is our product. How will you prepare this? That we are going to write down here. So first of all, draw the structure. 1-propoxypropan. Propan is there, so you can see 3 carbons are there. Okay, because it is propan. Now with that propoxy is attached. Prop plus oxy means 3 carbons, with that oxygen is attached. So you can see these are 3 carbons, with that oxygen is attached. So this is the simple structure of 1-propoxypropan. Okay, again what you have to do, this is propan, so draw 3 carbons. Now with that on first number carbon we have propoxy. Propoxy means propan plus oxygen. So you can see 3 carbons, with that oxygen is attached. This one is propoxypropan. Now how will you prepare the starting material? So you have to break this bond, carbon oxygen bond. Okay, now on oxygen side add sodium, and remaining part means this is alkyl group, with that add Cl. So you will get your starting material. Now you can see this is CH3CH2CH2ONa. With oxygen I have added Na, and with this alkyl group, 3 carbons alkyl group, I have added Cl. So you can write simple reaction. It will give you 1-propoxypropan and NaCl, that is our byproduct. Now look at the second question. We have ethoxybenzene. Now eth means 2 carbons and a benzene structure is there. So first of all draw the benzene. On that we have ethoxy group, means eth means 2 carbons, with that oxygen is attached. So this is our ethoxybenzene. Now break into 2 parts to prepare the starting material. Now remember that whenever benzene structure is there, oxygen goes with benzene. Again, oxygen goes with benzene. So this bond you will break. Oxygen is now on benzene ring. Now with oxygen add Na, and with remaining alkyl group add Cl. So this will give you starting material. You can see on benzene ring we have ONA, CH3CH2, Cl, that is our second starting material. It will give you ethoxybenzene and NaCl as product. Now in question number 11.24, two more examples are there that you have to do it yourself. If you have any problem, you can contact me. Question number 3 and 4, these are 1 and 2. 3 and 4 you have to do it yourself. Here I am going to discuss question number 11.25. The question is like this: illustrate with example the limitation of Williamson synthesis for certain types of ether. Okay, so we have to discuss the limitation of Williamson synthesis. Now Williamson synthesis is preparation of ether. Okay, Williamson synthesis is preparation of ether. Now in Williamson synthesis, SN2 mechanism takes place. SN2 reaction mechanism takes place. Now we have learned SN2 reaction mechanism. In that we have learned that 3-degree alkyl halide, it gives SN2 reaction mechanism, but it is difficult. Okay, again SN2 reaction mechanism is difficult in 3-degree alkyl halide. So if we have 3-degree alkyl halide, some other reaction takes place. Take this as an example. You can see this one is our starting material, CH3Cl. 1-degree alkyl halide is there. It is not 3 degree. This one is 1-degree alkyl halide. On second hand we have alkoxide, sodium alkoxide ion. Sodium alkoxide is there. Now if we react this both, reaction will take place and form ether here. You can see Na and Cl will be removed and this ether will get. But what if we have 3-degree alkyl halide? You can see this one is 3-degree alkyl halide. With that, this is our second starting material, CH3ONa. Now what will happen? Instead of removing NaCl, elimination reaction takes place. Here Cl and hydrogen from adjacent carbon will be removed. You can see this product will get propene, 2-methyl propene will get as product, and hydrogen that goes with CH3O to form alcohol, and NaCl will be our other byproduct. So elimination reaction takes place here. So it is not possible to react 3-degree alkyl halide with in Williamson synthesis. Again, what is limitation? It is not possible to react 3-degree alkyl halide in Williamson synthesis. Okay, so that's it for today. Thank you.